All right, good morning, guys. Today we're going to be looking at solving quadratic equations by factoring and graphing. So we've already dealt with factoring before, and so we're just going to be using the methods that we've used before for factoring, but we're going to actually be solving for something, because I know before this lesson we would just factor using either the difference of squares, perfect square trinomial, or the table method. But that's all we would do with that, right? We wouldn't really solve anything. In this lesson, we're going to actually solve for values of x. And then, we're also going to solve with graphing as well. But the main idea is being able to recognize the relationship between the solutions that we get when we solve an equation, and the zeros of its related function. And what are zeros again? Zeros is another name for x-intercepts. Okay, so we have zeros are x-intercepts. Keep that in mind as they come up in the problems. So first of all, let's look at what quadratic equations, what they look like, right? So when a quadratic function is set equal to a value, the result is a quadratic equation. Okay, so quadratic function is something of the sort. So quadratic function is the one we were looking at in the last lesson. F of x equals something with x squared in it. But when you put an f of x on it, it's called a function. And then when you set it equal to 0, when writing a quadratic function as a related quadratic equation, f of x is replaced with 0. So we're going to be looking at the different forms that they can appear in. So here, like for example, here, standard form, you have function notation. So you have f of x equals to some sort of function. And we've seen functions like this when we do the table method or a perfect square trinomial. And this is called standard form. So remember, when we put things in order from largest power of 2, power of 1, and no power. But whenever you have a function and you set it equal to 0, or you set it equal to any number, it changes from being called a function to an equation. So a function has this f with parentheses notation. An equation is equal to a number. Most of the time it's 0, but if it can be equal to any number. Then we also looked at, in the previous lessons, we can use different methods to factor. We can use the table method, perfect square trinomials to factor. And in factored form, you have two parentheses, and it's plus or minus a number. So there's a space here where you would put a number, whatever those numbers will be. But instead of putting f of x, if you set it equal to 0 or set it equal to a number, it changes from being called a function to being called an equation. And these last two examples are just different ways you can solve them. You can have the 0 or the number on the left side of the equals or on the right side of the equals. And then the last form is in vertex form. This is what we were using last class when we were graphing. Vertex form has, a plus or minus inside the parentheses and a plus or minus outside the parentheses to tell you if we're moving horizontally or if we're moving vertically. And there's a number in front that tells you about compression expansion, or reflection. Okay, so we have expansion, compression, reflection. We have horizontal translation, and we have vertical translation. So this is vertex form. And when you take this function and you set it equal to 0, it changes from being called a function to being called an equation. An equation equals 0, function equals f of x. All right. So let's see, how do we solve these, right? So I'm going to break this down into processes. So solving quadratic equations, there are several methods for finding solutions to a quadratic equation. This lesson will focus on factoring and graphing. Okay, so just for this lesson, we're going to focus on these two methods. So let's see, how do we start this? Getting your equation ready to factor. Get your equation ready to factor by moving all terms to one side. Okay, so in these two examples here, we're just going to practice moving all the terms to one side. So let's take a look at this one here. So I have n squared and plus 2n on the left side, and I have 8 on the right side. So how do I get everything to one side, right? Well, I have 2 terms on the left and 1 on the right. So I might want to move the one on the right to the left. So what's the opposite of a positive 8 and negative 8? So I'm going to subtract 8 on both sides. That's going to leave me with n squared plus 2n minus 8 equals, what's 8 minus 8? 0. So in this one, we're just, making sure that we set everything equal to 0, or we get everything to one side. And so our task is complete for this problem, because that's all it's asking for. It says move all terms to one side. So we moved n squared, 2n, and minus 8. So they're all on the left, and there's nothing on the right side. Let's look at example 2. Now, in example 2, I have a to the power 2, I have a, and I have a number. But notice that we have 2 terms on the right and 1 term on the left. So what's more work, right? Is there more work moving 2 things to the left or moving 1 thing to the right? Right? I would say it would be more work to move 2 items to the left. So it should be easier just to move 1 item to the right. So let's move the negative 2a squared to the right. Another reason why I want to move the a squared term to the right is because I always want the term with the largest power to be positive. It makes the factoring process easier when we get to the factoring. So I'm going to move the negative 2a squared to the right. So to do that, I need to do the opposite, right? So add 2a squared on both sides. That's going to give me a 0 equals, bring down the 18, bring down the minus 12a, and bring down 2a squared. But then I'm going to reorganize these terms from largest power to smallest. So I'm going to do 0 equals 2a squared minus 12a positive 18. Okay. So notice I didn't change the signs, right? I just put the positive 2a squared at the front. I put the negative 12a second, and then I put the positive 18 last, so that it's in standard form. Okay, so I'm done with these two examples. Let's go over to the next part. The next part is called the zero product property. Product means multiplication. Okay, just keep that in mind. Product means multiplication. Let me choose a different color. So product means multiplication. All right, so it says if the left side of ax squared plus bx plus c equals 0 can be factored, then the equation can be solved using the zero product property. Okay, so it's saying, you know, after we've moved all the terms to one side, if the terms on the left side or on either side, because remember example 2, everything was on the right, but if you have this 3-term setup, you want to ask yourself, can it be factored? If it can be factored, then you can use the zero product property. So let's see, what does the zero product property state? It says if the product or if the multiplication of two factors is 0, then at least one of the factors is 0. So it's using the idea that, you know, if I have two numbers and I don't tell you what they are, but I say, you know, I multiplied two numbers a and b, and that they gave me an answer of 0. When I multiplied two mystery numbers a and b and I multiplied them, I got 0. So then what can you assume about a and b? Right, you can either say that maybe a is 0, because anything times 0 is 0, or you can also assume that maybe b is 0. And the last assumption is both a and b are 0. Okay. So how does that apply to factoring and working with factors? So let's look at example 3 and 4. Okay. So let's say we're in a certain process and we've already factored on the left side, and so we're left with these two factors. So these two factors, these two parentheses, are multiplying. So let's say we call this a and we call this b. So again, if I have two terms that are multiplying and they equal to 0, then you can assume that either the first term is 0 or the second term is 0. So this is our assumption here. We can assume that either x minus 3 is 0 or x plus 7 is 0. And that gives us two equations to solve, because the instructions say use the zero product property to find the values of x. So let's solve for x. So on the left here, we're going to add 3 on both sides. It's going to give me x equals 3. And then on the right here, minus 7, x equals negative 7. Okay. Let's try that with example 4. So example 4 has y multiplied with y minus 5. So we can say that either this is my a, this is my b. And again, if I'm multiplying two items and they equal to 0, then the assumption is that either the first item is 0 or the second item is 0. So we have either y equals 0 or y minus 5 equals 0. Now, the first part gives me the answer right away. It's telling me that y equals 0. But for the second part, I have to do the opposite of subtracting 5, which is adding. So I add 5 on both sides. Y equals 5. So my two answers are y equals 5 and y equals 0. Okay. Now, putting it all together, we get to the main steps of solving a quadratic equation by factoring. So let me zoom out here. Okay, so solving a quadratic equation by factoring, you're going to use the following steps. Number 1, get your quadratic equation ready to factor by moving all the terms to one side. So we have to move all the terms to one side. Then step 2, factor. Remember, when we're factoring, we can look for a GCF first. Check to see if there's any GCF first. Then check to see if it's a perfect square trinomial or a difference of square. So check if it's a perfect square or if you can use a table, and you're going to do this process second. So first, check to see if there's any GCFs. Second, check to see if it's a perfect square or if you can use the table to factor. And then the last thing is use the zero product property. The zero product property. So that's saying, if I'm multiplying two terms, A times, let me use a different color here, A times B, and it equals to 0, then that means that either A equals 0 or B equals 0. Okay, so again, the steps are: move all the terms to one side, factor by looking for a GCF or the table method or perfect square. Then third step, use the zero product property. So let's put it all together. Let's go to example 5, I believe. Yes, example 5. Let me zoom in. Okay. Go. Okay. Find all the possible solutions to the quadratic equation. All right. So this one, step 1, move everything to one side. Well, the nice thing about this one is that it's already done. The problem already started out that way. The second step is factor. Is there a GCF? They don't have x's in common, and they don't have numbers in common. I mean, the only GCF is 1. But if you notice, there's a subtraction happening. If you remember when we used to factor before, we would ask ourselves, can I square root the first term? Can I square root the last term? And so, yeah, I can square root these terms, and it ends up becoming a difference of squares. X and X, 9 and 9, and one of them is plus, the other is minus. Because positive 9 times negative 9 is negative 81. And what's 9 minus 9? 0. All right, so we've factored. And so step 3 is use the zero product property. So the zero product property states that if this is my A and this is my B, and they're multiplying and they equal to 0, that means that either x plus 9 equals 0, or it means that x minus 9 equals 0. So I subtract 9, x equals negative 9, or add 9, x equals positive 9. So those are my two solutions. Those are my two solutions, negative 9 and 9. So check off this rule. So these are the 3 rules. So again, move everything to one side. It was already equal to 0. Second step, factor. Third step, zero product property. Okay, example 6. So again, step 1, move to one side. So I can move the 16x to the left, so minus 16x minus 16x. It's going to give me 2x squared minus 16x equals 0. So checked off that part. Step 2, factor. Check to see if I have a GCF. I think I do. They both have an x. They both are divisible by 2. So 2x is my GCF. So remember, I would usually divide both terms by my GCF, and then I would put the GCF in the front and divide. So what's 2 divided by 2? That's 1. X squared divided by x, that's x, minus 16 divided by 2 is 8. So that's as much as I can factor. So check mark on that. So step 3 is the zero product property. So this is my A, this is the B, and so that means that two things are true, either 2x equals 0 or x minus 8 equals 0. So over here I can solve for x by dividing by 2. X equals 0. That's one answer. And on the right side I can add 8, x equals 8. Right, so that's the product property. So all 3 steps are checked off. I'm done. Example 7. Move everything to one side. let's move everything to one side first. So in this case, if you remember, I think it was example 2, I have 2 terms on the right, 1 term on the left. It's easier for me to move 1 term to the other side. So the opposite of negative x squared is positive x squared. So that's going to give me 0 equals x squared minus 6x plus 9. So that's step 1 is checked off. Step 2, factor. So if I'm looking at factoring, could I use the table method? Yeah, or I can do perfect square trinomial. If I do the table method, looking for 2 numbers that multiply to give me 9 and add to give me negative 6. So that would be negative 3 and negative 3, because negative 3 plus negative 3, this gives me 9, this gives me negative 6. So those are my factors. So I'm going to write 0 equals x minus 3, x minus 3. And again, I'm just copying the 0 over here, copying the equal sign, and this part, x squared minus 6x plus 9, became this part. Because negative 3 times negative 3, positive 9. Negative 3 plus negative 3 is negative 6. So we have factored. And then step 3, the 0 product property. So if this is my A, this is my B, that means that x minus 3 equals 0. So plus 3 means x equals 3. And I'm not going to do the other part because it's the same thing. They're both going to give me x equals 3. And then example 9. Move everything to one side. So I have 1, 2, 3. I have actually 2 terms on the left, 3 terms on the right. Again, I also want to make sure that the x squared terms are positive. So I'm actually going to add x squared. And I'm going to add 10x. So I'm kind of doing 2 processes at the same time. So that's going to give me x squared plus x squared is 2x squared. 5 plus 10 is 15x. Bring down the equals. Bring down the 8. Negative 10 plus 10 cancels. Negative x squared plus x squared cancels. And then one more step, I'm going to subtract 8. Subtract 8. Equals 0. And over here I have 2x squared plus 15x minus 8. So I've completed step 1. I'm going to move to one side. Step 2, factor. So maybe I can do the table method and do the table over here. So I'm looking for two things that multiply. But I want to make sure I have space. So I'm going to delete the steps because we're going to go over them. We've been going over them for a while, but I want to make sure I have space for the table. So let me put my table. Oh. Let me put my table over here. Then I'm going to use a couple of colors so we can remember from last time. So we're multiplying 2 times negative 8, that's negative 16. And we're looking to multiply here. And then the plus 15 is what we're looking to add. So two numbers that multiply to give me negative 16 and then add to give me 15. So that's 16 times negative 1 gives me negative 16. And 16 plus negative 1 gives me positive 15. Right. And then we would usually do, we would say, okay, well this becomes 2 parentheses here equals 0. We do x plus 16, x minus 1. But remember, there is a 2 right here in front. So we have to divide both of these by 2. That's going to give me x plus 8 and 2x minus 1. And then we can use the zero product property. We say that this is A, and let me use a different color. This is B. Then we can say that either x plus 8 is 0. So subtract. That means x equals negative 8. Or we could say that 2x minus 1 equals 0. So that means we add 1 on both sides. We get 2x equals 1. Then divide both sides by 2. X equals 1/2. All right. So my two answers here are x equals negative 8 and x equals positive 1/2. Right. Let's go to the next part. The next part is talking about quadratic equations and functions. It says if a quadratic equation can be factored, the factors can be used to find the solutions to the quadratic equation. Solutions to the quadratic equation are the zeros of the related quadratic function. The zeros are the x-intercepts of its graph. So the example here is the following. So if I graph this function, it gives me the following graph. And if I want to identify the zeros of the function, again, remember these are the x-intercepts. It's going to be here and here. So the x-intercepts are at x equals, actually let me write it in black. X equals 3 and x equals 7. You know, that's if I have the graph there, I can see clearly that the x-intercepts are 3 and 7. But notice over here, I have the same equation. Use a different color. I have x squared minus 10x plus 21, and then I have x squared minus 10x plus 21. So it's the same equation, but one of them has an f of x, which means, you know, I can graph that. The other one is equal to 0. It means it's an equation. So I have a quadratic function because I have this f of x notation, and on the right I have a quadratic equation because it's equal to 0 or a number. So what are we going to get when we solve? So first step, move everything to one side. Everything is already on one side. So step 2 would be factoring. And we can actually use the table method. And so we're looking to multiply to get 21 and add to get negative 10. Actually, let me write it in the middle so that there's more space. So again, I'm looking to multiply to get 21 and add to get negative 10. So that's negative 7 times negative 3. That gives me positive 21. And negative 7 plus negative 3 is equal to negative 10. So 2 check marks. So that means that my answers are x minus 7, x minus 3 equals 0. Do I have to divide these by anything? No, because there's nothing in front of the x squared. And then I can say if this is my a and this is, horrible scribble, and this is my b, then I have either x minus 7 equals 0 or x minus 3 equals 0. So plus 7 means x equals 7 plus 3 plus 3, x equals 3. So the solutions are x equals 7 and x equals 3. So again, the order doesn't matter, but I did get the same answers, right? 7 and 3. So a couple things to note about the quadratic function. Let me zoom in here. Is that the quadratic function can have 1, 2, or no solutions. And let me fill in the missing arrows here. Right, so if it has 2 solutions, that's referring to the number of intercepts. So it has 2 zeros, right? Two x-intercepts. If it has one solution, it has 1, 0, 1 x-intercept, and then no solution means that the graph didn't even intersect the x-axis. So no intersection. Okay, so we have two more examples. And in these last two, let me check, I think, is it two more? Yes, it is. Okay, so in these last two examples, we're doing graphing and solving. So they want us to graph this function and find the x-intercepts, or zeros, then find the solutions of the equation on the right by factoring. Now, we did this when we worked on absolute values, so it should be familiar. Here, if I break down the graphing process, there is a negative, so that means that there's reflection over the x-axis, and then I have plus 3 inside the parentheses, so that means a horizontal translation 3 units left. So those are my notations for the transformation that's happening. Let me zoom out a little bit so we can graph. So if I'm going to graph down here, if I have my parent function points, that's 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And so there's a reflection. So these pink points are just showing the reflection. So the black parent points are now reflected downward, and then there's a horizontal translation 3 units to the left. So that's going to cause these points to move 3 units to the left. Give me those points, and then I can delete these extra ones. Right, so that means that the function that it's referring to at the bottom here, it says the zero of, and so there we're just going to copy the function is negative x plus 3 squared. The x-intercept happens at negative 3, 0, or you could say x equals negative 3. And over here on the right, following the steps, right, move everything to one side. Everything's already set up to one side. So at least we can get rid of the negative 1 by dividing both sides by negative 1. That leaves us with x plus 3 squared equals 0 divided by negative 1 is 0. Then x plus 3 squared can be written as x plus 3 times x plus 3. So that means that from here that x plus 3 probably equals 0 if we use the zero product property. Then we subtract 3 on both sides. X equals negative 3. So the solution of the problem negative x plus 3 squared equals 0 is x equals -3. And then you should notice that they match. So let's try that one more time with example 10. Right. Yes. All right. So in example 10, all we're doing is we have a transformation of -1. So that means we have a vertical translation 1 unit down. So if I use the parent points, and I'm just moving all the points 1 unit down, it gives me the following. Right. And so we're going to write the zeros of the function f of x equals x squared minus 1 are, we have two x-intercepts actually. This one and this one. So that's at -1 and +1. So we have an x-intercept at -1, 0 and 1, 0. Or we can say x equals -1, x equals 1. So now on the right side, we can use the rules for solving quadratic equations. You know, first step, move everything to one side, but everything is already set to one side. So the next step would be factoring. So I can ask myself, you know, can I square root the first term, it's x? Can I square root the last term, which is 1? So that gives me put more space on this. It gives me the situation where I have x and x. I have 1 and 1, and one of them is plus, the other is minus. So if this is my a and my b, that means that either x plus 1 equals 0 or x minus 1 equals 0. So -1, x equals -1, +1, +1, x equals +1. So the solutions of the equation x squared minus 1 equals 0 are x equals -1 and x equals 1. All right. So again, we should compare both and notice that both give us the same x values. So if I have a function and I graph that function, then the x-intercepts that I get correspond to the solutions of the quadratic equation. So thank you for joining me today. I'll see you guys in class. If you have any questions, I'll be free to answer them in class. Have a great rest of your day.